Today we're going to work on Oklahoma State Standards 7.N.2.3 and 7.N.2.5. First we'll talk about adding numbers with different signs. Here's our first problem. 14 plus negative 41 plus 29. So, if we're going to add integers, there's actually 3 of them here. So I want to start with the first 2. This one over here in the end, we're going to say this one for last. So, we're just going to do 14 plus negative 41 to begin with. So 14 plus negative 41. What we're going to do is we're going to keep the sign of the number that has the highest absolute value. And the absolute value can be found by looking at the number without its sign. So 14 is the absolute value of 14, and 41 is the absolute value of negative 41. So 41 is the highest absolute value. So this 14 plus negative 14 answer is going to be a negative answer. And then we are going to take the 41, the largest number, and subtract it from 14. We're going to have to borrow, because you cannot take 4 from 1. So the 1 is going to turn into 11, and the 4 is going to turn into 2. 11 minus 4 is 7, and 3 minus 1 is 2. So we have negative 27 for the first part. And we're going to use this one that we left at the end. Now we're going to bring it down next to our negative 27. And we're left with negative 27 plus 29. Now, the absolute value of negative 27 is 27. The absolute value of 29 is 29. And the 29 has the largest absolute value. So we're going to use the sign of the 29, which is positive. So that means our answer is going to be positive. So now we just do 29, take away 27. 9 minus 7 is 2. 2 minus 2 is 0. So our answer is a positive 2. And I'll put our answer with a purple square. Now we're going to find the sum with fractions and mixed numbers and negative and positive numbers all mixed up together. So here it is, our problem that we're going to work. It is 2 1/4 plus a half plus negative 3 1/6. Now, I want to start with just this first part. Put a rectangle around this last part, just so that we won't confuse it with what we're working with right now. So we'll start with 2 1/4 plus a half. So what I want to do is I want to go ahead and turn this mixed number in the front into a fraction so that it will be easier to solve this problem. To do that, we are going to keep the denominator and the fraction the same. And then we are going to take that denominator and multiply it by the whole number. So 2 times 4. 2 times 4 is 8. And then we're going to add the number in the numerator position, plus 1. And 8 plus 1 is 9. And we're keeping the denominator, which is 4. And we're going to bring down this second part, which is plus 1/2. Okay, so we have 9/4 plus 1/2. Okay, now to add these, we have to have the same denominator, because if you don't have the same denominator, you're going to have to fix your fraction so that you have the same denominator. So this is a 4 and this is a 2. What we need to do is find the common denominator between the two. Okay, to find the common denominator, you find the smallest number that each denominator will divide into. Okay, so let's do 4 because 2 times 2 is 4, so that is the smallest. And so our first fraction is going to stay the same because it already has a denominator of 4. But this fraction right here, we have to ask ourselves, what would turn this 2 into a 4? Well, if we multiplied it by 2, it would be a 4. And everything that we do to the denominator, we also have to do to the numerator. So we multiplied the bottom by 2, so we're also going to have to multiply the top by 2. So 1 times 2 is 2. And our new problem is 9/4 plus 2/4. And 9 plus 2 is 11. And the 4 and the 4 remain the same in the denominator. So now we're left with 11/4. 11/4. So we're going to take the 11/4. The 11/4, and we're going to add it to the rest of our problem over here that we put in a rectangle. Plus -3 and 1/6. So I'm going to want to turn this mixed number into a fraction also, so that it will be easier to add into this fraction. To turn this mixed number into a fraction, we keep the denominator the same, which is the 6, and then we multiply 6 times 3, which is 18, and then we add the numerator to that 18. So 18 plus 1 is 19. And we're going to keep this negative symbol, negative 19/6. And we're going to add that to 11/4. This is getting a little sloppy, so I'm going to do some erasing that top part. No need to look at it, because here's our new problem. 11/4 plus -19/6. Okay? I'm going to go ahead and erase this over here as well. This is what we're left with. Now, look at our denominators. They are not the same. So we have to make them the same. So we find the common denominator. And the common denominator of both of them is 12. So I'm going to write 12 as the denominator for both of these. How do we go from 4 to 12? Well, we multiply times 3 to go from 4 to 12. And anything we do to the bottom, we have to do to the top. So we'll multiply the top by 3 as well. 11 times 3 is 33. So our new fraction from that one is 33/12. Make sure we write these the same. And over here, how did we go from 6 to 12? Well, we multiplied by 2, because 6 times 2 is 12. And anything we do to the bottom in the denominator spot, we have to do to the numerator spot. So we'll multiply this times 2 as well. So let's see what 19 times 2 is. 9 times 2 is 18. Put an 8 there and a 1 there. 2 times 1 is 2, plus 1 is 3. So we get 38. So 38/12. I'm going to erase all this, and we're left with our new problem. 33/12 plus -38/12. Our denominators are going to stay the same. Equals something with a denominator of 12. And so to find the numerator, I just add 33 and -38. And remember earlier we talked about when you're adding numbers with different signs, like this one's negative and this one's positive, you pick the sign of the one with the highest absolute value. And so 38 is higher than 33, so this one has the highest absolute value. So this negative symbol is going to be our answer. And then we do 38, take away 33. You subtract the biggest number from the smallest number. 8 minus 3 is 5, and 3 minus 3 is 0. So our answer is negative 5/12. Right there, negative 5/12. Okay, now we're going to talk about interpreting negative number statements. Tyler and Milo are digging in the yard with their shovels. Tyler dug a hole that is 24 inches deep. And Milo's hole, he dug, is 8 inches directly above that. So Milo dug a hole that is 8 inches directly above Tyler's 24-inch deep hole. 8 inches directly above. Okay? The following equation describes a situation. Negative 24 plus 8 equals negative 16. Okay? What does the negative 16 tell us? This number right here, the negative 16. What does that tell us? Does it tell us A, B, and C? A, Milo dug 16 inches with a shovel. Does it tell us B, Milo's hole relative to the surface of the land is negative 16 inches? Or does it tell us none of the above? Okay. So Milo dug 16 inches with his shovel. Yes, it does tell us that Milo dug 16 inches with his shovel. Milo's hole relative to the surface of the land is negative 16 inches. Yes, that is correct also. It's a real wordy and confusing, but it is correct. None of the above? No, that is not true. So Tyler has dug 24 inches below the surface of the ground. The more below the surface of the ground, the more negative we are. That means the beginning of the surface of the land where the digging began is 0. And Milo has dug 8 inches above Tyler. That is why we added 8. To figure out Milo's depth of negative 16 inches, every statement is correct except the last one. Next, we're going to talk about multiplying and dividing negative and positive numbers. Okay, so we have to know the rules. A positive number times a positive number has a product that is positive. An example of this is 6 times 6 equals 36. Positive number times a positive number equals a positive number. Okay? Here's another rule. A positive number times a negative number has a product that is negative. Here is an example of this. 6 times negative 6 equals negative 36. That's a positive times a negative equals a negative. Here's another rule. A negative number times a negative number has a product that is positive. Here's an example of this. Negative 6 times negative 6 equals 36. Negative times negative equals positive. You just have to know the rules for this multiplication. And here's another rule for negative and positive numbers. When something is multiplied by 0. So negative 6 times 0, well, if we think back when we learned multiplication, we were told that everything times 0 is a 0. So that's right. That's the rule. Even if it's a negative number, anything times 0 is always a 0. Now the good thing about that is you don't have to really memorize two different sets of rules for multiplication and division, because they work for division the same rules that work for multiplication. So a positive number divided by a negative number has a quotient that is negative. Here is an example. Negative 36 divided by 6 equals negative 6. Negative divided by a positive equals a negative. And when you divide two negative numbers, then the quotient is positive. Here's an example. Negative 36 divided by negative 6 equals 6. Negative divided by negative equals positive. Okay? And of course, a positive number divided by a positive number has a quotient that is positive. Here's an example. 36 divided by 6 equals 6. Positive divided by positive equals positive. Okay, and as in multiplication, the rules are the same in division for dividing by 0. 6 divided by 0 equals 0. So multiplying negative and positive numbers. Let's just talk about a problem here. Tyler drank 2 Dr. Peppers each day for 5 days. The following equation describes the situation. Negative 2 times 5 equals negative 10. Okay? And what does the negative 10 tell us? This negative 10, what does it tell us? Does it tell us A, Tyler decreased the number of Dr. Peppers he had by 10 over a 5-day period? Does it tell us B, Tyler consumed 10 Dr. Peppers in 5 days? Does it tell us C, none of the above? Well, let's look at the first one. Tyler decreased the number of Dr. Peppers he had by 10 over a 5-day period. Well, he had to have those Dr. Peppers to consume them, and when he consumed them, he no longer had those 10. So yes, this one is correct. But let's look at this one. Tyler consumed 10 Dr. Peppers in 5 days. Yes, he consumed them. They are no longer here. It does tell us that. None of the above. No, it does not tell us that. When Tyler drank the Dr. Pepper, he no longer had them because he drank them. That is the -2 in the equation. The 5 was the amount of days, and -2 and 5 are multiplied to see how many less Dr. Peppers he had when consuming them. Every statement is correct except the last one. Okay, now we're going to talk about combining like terms. And there's some things that we need to know first. This number right here is called a coefficient. C-O-E-F-F-I-C-I-E-N-T. Coefficient. Okay? A coefficient is a number used to multiply a variable in an algebraic expression. Okay? And this right here, this x, is called a variable. V-A-R-I-A-B-L-E. Variable. Okay, let me tell you what a variable is. A variable is a quantity that may change within the context of a mathematical problem or experiment. Typically, we use a single letter to represent a variable. The letters X, Y, and Z are common generic symbols used for variables. Okay? Now I'm going to show you a problem that has a coefficient and a variable in it. But before I show you that, I'll just show you a regular addition problem. 2 plus 2 equals 4. So, oh, look at this. 2 markers plus 2 markers equals 4 markers. 1, 2, 3, 4. It's as simple as addition. Let's take a look at that so I can explain why it's as simple as addition. Okay, so if we were to add variables in there, we could say 2a plus 2a equals 4a. So when I said 2 markers plus 2 markers equals 4 markers, it's the same thing as saying 2a plus 2a equals 4a. Okay? But what if there are other variables in there? For example, what if we had, let's say 2a plus 3y plus 2a plus 2y. Okay. I bet you're wondering how we would do that. Okay, equals. First, what we would do, let me get a different color, is we would find the a's and group them together. And then our y's, we would group them together. And we would find out or solve 2a plus 2a, do our a's, and then we'll go back and do our y's. So 2a plus 2a would be 4a plus, let's do our y's, 3y plus 2y is 5y. There's the answer. 2a plus 3y plus 2a plus 2y equals 4a plus 5y. Now we're going to evaluate expressions that have exponents. And you might have seen a big number with a little number up in the corner. Well, this little number, that's called an exponent. That's E-X-P-O-N-E-N-T, exponent. Okay? So let me tell you what an exponent is. An exponent is a quantity representing the power to which a given number or expression is to be raised, usually expressed as a raised symbol beside the number or expression. Now we're going to see a problem that has exponents in it. Our problem is 2 to the third power times 2 to the second power. So this 2 to the third power, it is the same thing as 2 times 2 times 2. This is the number 2, and it's multiplied by itself 3 different times. 1, 2, 3, because it's to the third power. Okay? And it is multiplied by this 2 to the second power. And the way we write 2 to the second power is 2 times 2. This big number is 2, and it's to the second power, so it's multiplied by itself. 1, 2 times. And when we solve this, 2 times 2 times 2 times 2 times 2, we will know the answer of 2 to the third times 2 squared. When an exponent has a 2 there, we call it squared. And when there's a 3, we call it cubed. And if it has a 4, we'll say to the fourth power. When it has a 5, we'll say to the fifth power, and so on. So, what is 2 times 2? It is 4. And then 4 times 2 is 8. And then 8 times 2 is 16. And then 16 times 2 is 32. So our answer is 32. 2 to the third times 2 squared, or 2 to the second, is 32. Thank you for listening to my lesson on Oklahoma State Standard 7.N.2.3 and 7.N.2.5. I hope that you learned from this video. Thank you.